Hi friends, welcome to the second tutorial. So in this tutorial we are going to discuss three things in continuation from the first one. So the three things that we want to discuss is number one, what do the machines really learn in machine learning? Number two, what is the guarantee that machines will actually learn anything? Then third, what is the general framework for any machine learning problem? So let's get started with the first question. When you say that machine has learned something, it means that machine has learned one of the possible two things, that the process that you're observing. Every process that you're observing, be it stock market return generation or customer churn or customer behavior, they're all dependent on some drivers. For example, stock return depends upon the last prices, volatility, volume, and many more things. Churn rate depends upon the customer behavioral clues and some other things. This means that there is a true output generating function from the drivers as input. So machine can estimate this true function by looking at the sample data. The second thing that machine learns is that every process is represented by a joint probability distribution between the output and the drivers, and machine can estimate this probability distribution. So summarizing, a machine learns a real output function and a real probability distribution. So let's take an example in Excel and Python. So here in Excel, in sheet 3, in column A, you can see that there's an output called Y, and in the B column there's an input called X. As we have discussed, that machine can learn the true function that spits out Y from X. This will be done using regression tool given by machine learning. We will not discuss here that why we choose this tool, but let's say it's given, and as a result the function that we learn is this function. That is y is equal to x into 0.98 plus 1.008. Now, we have discussed this in the first session. Now, in this sheet, that is sheet 1, we are calculating the probability distribution of the y variable. We have used COUNTIF function. Here is the formula. It is basically counting in a range based on a certain criteria. We can also use frequency function, but let's keep things simple. Now, as I have said that we will code everything in Python, so let's look at the Python code also. So for going to Python, we go to search and we look for IDLE, that is the Python editor. It opens up here. Let's enlarge it. Then we go to file, then we look at recent files, and then we open regression.py. So this is the actual file. Now, let's look at this file. So, as I have said, that this file will do exactly the same thing that we have seen in Excel sheet. So basically, in these two lines, the lines that I've highlighted, we are creating a file object. In these two lines, we are reading the content. The next two lines, the content that we are reading is following. From the sheet 3, we are going to read Y, and we're going to read entire X. Let's get back to this code. Now, in the next line, that is this one, we will call a linear regression object that we have transported from sklearn module using this line. This creates a linear regression object, and the next two lines we change the data structures into array data structures using NumPy, because that is the allowed format for input to the linear regression object function. And in the last three lines, we are just going to output the results that we've already seen in Excel. So let's press F5, which is the run command for Python. And there you go. This is the correlation between X and Y. So it is really high. You can see here. And this was the histogram that I generated that we already saw in Excel here. Let's go back and look at this histogram. Now they don't look similar. The reason is that the reason is that here I have used very wide bins, but in this case I have used very narrow bins. You can look at the code also. That here I have used bins from 0 to 10, 10 to 20, 20 to 30, and 40 to 50, so on. And in Excel sheet I have used the bin of from 10 to I've used the bin of 10 to 20, 20 to 30, 30 to 40, 40 to 50, but nothing onwards. So now let's answer the question that what is the general framework of a model building exercise? So there are 5 things actually, and here are those 5 things. We must understand the problem, then we must collect the right data, then we should make a model, then we should get the parameters of the model by minimizing the cost function, and then we should evaluate the model. Now here there are a lot of technical details. For example, cost function can be MAP, MLE or least squares. The minimization can come by random search, simulated annealing, hill climbing or genetic algorithms. Then model evaluation can be done on many factors such as out of sample performance, scalability and learning rate. However, the most important piece of any machine learning problem is making a model. It means 3 things. Number 1, choosing the right tool, that is a linear regression or neural network. Then number 2, deciding the features, that is how to transform the collected data, maybe by dimensionality reduction or maybe by multiplying 2 features. Maybe we also have to convert the distribution to the normal by taking logs. The thing for deciding the the third thing is deciding the complexity of the model, which means how many features you want to keep in your model. If you choose a very complex model, then you can end up memorizing entire sample, but out of sample performance will be really bad. So now the question is that how do we decide a model? Well, we do that iteratively together with evaluating each model. We will explore all of them gradually. In the next section, we will cover recommended systems as per the above described framework for modeling a problem. So thank you.